Hello everyone. Welcome to the part 3 of a lecture series of uh, numerical matrix methods for solving the system of linear algebraic equations. So let us take one small example. Again, for simplicity, I am going to consider the system of three equations in three unknowns. So the next step is to write this system as a matrix equation, and you can see that I have written this system as a matrix, the coefficient matrix A, and the solution matrix X, and the constant matrix B. Okay, so what do we do now is, once we have this equation, now we are going to write A as a product of LU. So if you have seen the earlier video, you know what is L and what is U. I want you to request now to pause this video, and I want you to run the previous video, that is part 2, simultaneously with this particular video, so that you will get an idea exactly what I'm doing in this video for solving the example using Crout's method. Okay, I hope that you are running the part 2 of this lecture series simultaneously with this video. Now let us go to step 2. So as step 2 I have explained in the earlier video, we write the elements of the matrix A here. So I'm writing A as in the expanded form, and then we are performing the matrix multiplication here to RHS. So what we do next is, we are actually going to uh, equate these two matrices, and since they are equal, their corresponding entries must be equal. So that means 2 must be equal to L11 minus 4 must be equal to L11 into U12, and 1 must be equal to L11 into U13. So what I'm going to do is, I'm going to solve this equality row wise. So I'm going to first look at the equality of first rows of these two matrices, and then find some unknown values, and then we keep on doing this till we find all the values of the matrix L and U. Okay, so here we are with the equality of the first row of the two matrices. So as we have seen earlier, L11 is equal to 2, that is A11, and the next equality was L11 into U12 is equal to minus 4. So minus 4 is actually A12, and then L11 into U13 is equal to 1, where 1 is actually A13. So here L11 is already calculated, and if you notice that I have written L11 in red color, it means that L11 for this equation is the known value. So using this, what I can do is, I can actually write what is U12, that is equal to minus 4 upon L11. But what is L11? L11 is 2. So finally what I'm going to get is, I'm going to get this as minus 2. So similarly, if you check this equation, I can write U12, or I can calculate U13 as 1 by L11. Again L11, we already know what is L11, that is 2. So therefore U13 is equal to half. In a similar way, we can calculate all the remaining values. I want you to pause the video, and then check these calculations that I have performed, and see if the values that I have calculated are correct. So once you do that, what we can do now is, since we have all the values of L11, L21, L31, etc., and U13, U13, U12, U23, so we have all the values of L and U. So we now proceed to the next step. So I have written the values of L and U, and I have written L as a matrix which we have evaluated the values, even U the values we have calculated, And now we go to step 4, where we are supposed to solve this system of equations. Here L, as I promised, that L will be known, so you know that now that L is this and B is this, and B is from the equation that we have earlier, that is the system we are supposed to solve, that is Ax equal to B. So now we have to solve the system by forward substitution. So what is the meaning of that? So what I'm going to do is I'm going to rewrite this system. So I'm going to get 2y1 equal to 4, then 6y1 plus 14y2 equal to 10, and minus 2y1 plus 2y2 minus, here we have minus 3 by 7 times y3, so minus 3 by 7 times y3 equal to minus 6. Okay, so when we rewrite the system, we get this equations, and you can see that here I'm going to get y1 first. So and then when I substitute this y1 into this equation, I'm going to y2 and so on, and therefore this procedure is called as forward substitution. So you can see that I have already calculated what is y1, y2, y3, and then I have substituted these values in this equation now, because our last step is to solve ux equal to y. So as I promised earlier, uh, u is known, u is from, I've taken from here the values of u. Now here finally we are going to calculate the solution matrix, that is x. Y is also calculated in the previous step. So I'm going to get now this matrix equation. Now we are supposed to solve this by backward substitution. So what is the meaning of that? When you rewrite this matrix equation in the equation form, now you can see the equation I've written here. So here what we do first is we first get the value of z, which we are going to plug into this previous equation, and substituting the value of z, we are going to solve this and we get the value of y, and then finally substituting value of z and y into the first equation, we get the value of x. So this process is called as backward substitution. So finally what we have here is we have the solution now. So the solution matrix x, y, z, and the solution is 2, 1, 4. So in a similar way, you can pause the video right now and then you can log into Moodle. I'm going to give you the login ID and password. There I have given you a lot of practice examples. You can select any of those examples and try to solve those examples. Although this system of equation is of 3 cross 3, you can try for 4 cross 4 or 5 cross 5. Okay, and keep on practicing. So this is the Moodle login and ID and password. This is ID, password. This is the website. You can log in here. There will be practice questions, quizzes, and also Scilab codes. Again, I would like to tell you that you can check whether the answer that you have calculated is correct or wrong using the Scilab codes available. Um, and if you have any queries, I have my contact information on Moodle. You can contact me by email for any queries. I hope you enjoyed this session. So in the next section, I'm going to cover Gauss-Jordan method. Thank you.